Hey guys, I'm going to go over 5.2. This is going to be, we're going to start learning about exponential, integrals, and derivatives. Okay, so this is your notes for 5.2. So just follow along with your book. So first of all, we're going to graph 2 to the x, 5 to the x, and e to the x in the same coordinate graph. Okay, so we're going to get our calculator out. And we're going to graph 2 to the x, e to the x, and 3, no, just kidding, 5 to the x. And we're going to look for similarities. So what do we notice about these 3 graphs? Some of them are a little skinnier, some of them are a little wider, but they all go through the point 1. Okay, so exponential graphs look like this. And they're all going to kind of do that same thing, but depending on if it's a 2 or a 5 or an e, where that point will go. Okay, so when we do an exponential function, it's always going to be a base with a variable exponent. So x is in the power. So anytime there's an x in the power, it's going to be exponential. Okay? So to graph an exponential function, we are always going to have a domain of negative infinity to positive infinity. And the range is always going to be from 0 to infinity, okay? So because it's never going to go negative, my function is always going to be above the x-axis unless I have a vertical shift. The function will always be above the x-axis. And then we do our transformations. So the horizontal asymptote is 0. And the way that we show that is the limit as x approaches negative infinity is 0, but as it approaches positive infinity, it goes up to infinity. The graph is continuous, it's increasing, it's concave up, and it's 1 to 1, which means it has an inverse function. It passes the horizontal line test and the vertical line test. The y-intercept is 0, 1, and then another key point is when you plug a 1 in, you get a. Okay, so on this one, if I plug a 1 in here, I get 2. So my ordered pair would be 1, 2. If I plug a 1 in here, I get 5. So my ordered pair is 1, 5. So notice that the bigger the base is, the closer to the y-axis. Okay, so the larger the base is, so if I have a base of 2, it's going to be at 2. If I have a base at 5, it's going to be up at 5. So this one's going to be 2 to the x, and this one's going to be 5 to the x. Now, this one's a little off because 3 right here would be your e to the x, because e is approximately 2.178 or something like that. So it's in between the 2 and the 5. Okay, so we're going to use adjustments, which we call transformations, to graph example 1. So e to the negative x plus 1. So if I have a negative x, that's a y-axis reflection. Okay, and then if I have a plus 1, that means I go up 1. So we're not going to use a calculator. We're going to just do it. So if my asymptote was usually at 0 and I shifted up 1, I now have an asymptote at 1. Okay, and then the graph usually goes through 0, 1. Instead, this is going to go through 0, 2. Now, if I draw my exponential graph, it would go like this and then go up. Okay, this would be the old one. But because it's a y-axis reflection, it's going to start high and then go low. Okay? So write an equation for the graph's asymptote. So the graph's asymptote is y equals 1. You could also write that as the limit as x approaches, this is positive infinity, f of x equals 1. Okay? All right, so now we're going to notice something really cool. Are you guys excited to find out this really cool thing that we find out? We're just going to graph e to the x. So e to the x is going to go through 1, and then it's going to be about 1, 2, like this. It's going to have an asymptote at 0. Okay? And then if I graph the derivative, so math 8 of e to the x, voila! Nothing changes. So what do we notice? E to the x and the derivative are the same. Okay, e to the x and the derivative are the same. So whenever I take the derivative of e to the x, I don't have to do anything. Now, it's obviously not going to be that easy because we're probably going to throw e to the u in instead of e to the x. So then we have to do the derivative of the u. Okay, so we're just taking derivatives here. So if I take the derivative of this, I write down my function. So e to the x squared minus 3x, and then I multiply by the derivative of the power 2x minus 3. Okay, g prime of t, write the function. So we always write the function, and then we multiply by the derivative. The derivative of negative 3 over t squared is, or over t, is positive 3 over t squared. That would be our u prime. Okay, and then here we've got 3 times the square root of e times this, the derivative of the square root of v is 1/2 v to the negative 1/2. Okay, now something that you have to notice here, this was an e, this was an e, this is a 3. So if it's not an e, I have to include my natural log of whatever that number is. So times by the natural log of 3. Okay, so we do it the same way we do e, but then we multiply by the natural log of our base. Multiply by the natural log of the base when it's not e. Okay, number 6. Find the relative extrema of f of x equals negative x e to the negative 2x squared. So to find relative extrema, I have to take the derivative and set it equal to 0. So f prime of x first times derivative of the second, this is e, okay, so this is my derivative of the second plus the second times derivative of the first. Okay, now we're going to set that equal to 0, and I'm going to clean it up a little bit. So 0 equals, so if I do this, I've got negative 4x times negative x is positive 4x squared e to the negative 2x squared minus e to the negative 2x squared. If I have to set this equal to 0, I have to try to factor. So I'm going to see that this and this are the same. So let's pull out e to the negative 2x squared and leave 4x squared minus 1. Okay, I set both of these equal to 0. Notice that 0 is an asymptote of e, so this is never going to happen. And this will be positive a half and negative a half. Okay, so these are our critical numbers. So when we find our critical numbers, we do an F prime number line. And F prime is this. Okay, so I'm looking at, if I plug a negative 1/2 in, this is never going to be negative. Okay, it's just going to get to be a smaller and smaller fraction. This is going to be negative 1/2 squared, which is 1/4. Okay, so anything less than 1/2 is going to stay positive, and same with greater than 1/2. But if I do a number in the middle, I get a negative. You just get that by plugging in numbers into, I just looked at this and I substituted a value in between here and here to see if I'd get a positive or a negative. So I know if I get a number less than 1, then it's going to be negative, because 1 minus 1 would be a negative number if it was at less than 1. That's how I figured that out to get this. Okay. All right. So now this is going to go up, down, and up. So if I look at this, I'm going to have a max at negative a half and a min at positive a half. Okay. So once I know where that's going to occur, I put this into the original function. So plug that negative 1/2 into here, and we get positive 1/2 e, and then 1/2 squared is 1/4. So this will be e to the negative 1/2. So 1/2 e to the negative 1/2. And we just leave it like that. Okay, and then the other one's going to be negative 1/2 e to the negative 1/2. Okay, so that is derivatives of exponents. Now we're going to go backwards and do integrals. So remember we had that hook on that was the derivative of the power. So I have to pay attention to that hook on this time and see what we get. Okay. All right, so we're going to do these. We have 7, 8, 9, and 10 are our examples. So if I did the x squared minus 1, I'm doing u equals x squared minus 1. du is 2x dx. 1 divided by 2x. Sorry, I'll try to write so I don't lose that. So 1 over 2x is what we're looking at, okay? So now I've got, I have to think about, there's going to be a 2x that would be a hook on, but because I have the x here, it will cancel out, but the 1/2 won't. Okay, if I put a 1/2 in here, I get 1/2 squared, so 1/4 minus 1. If I change that, I would get 1/4 minus 1, so negative 3/4. And then if I plug a 0 in, I get negative 1. And this is going to be 4 to the u times x times 1 over 2x times du. So those x's will cancel out. And we're left with 1/2 times 4 to the u du. And that's what we're going to be taking the integral of. So the integral of 4u is going to be, look over here at your integral rules, okay? I'm looking at this one right here at the bottom. Okay, so this is 4, so it's going to be 4 to the u divided by the natural log of a, which is 4. Okay, so let's write this right here. So we're going to write our a to the x, make sure I get that right, over the natural log of a plus c. Okay, so a to the x is going to go on top. This is like our 4 to the u. So I'm going to start by writing 4 to the u. Okay, and then I'm going to divide, I keep my 1/2, and then I divide by my natural log of a, which is the natural log of 4. And that's going to be evaluated from -1 to -3/4. Okay, so if I plug a -3/4 in there, I get 4 to the -3/4 divided by the natural log of 4. And then when I plug a -1 in, I get 4 to the -1 divided by the natural log of 4. And I'm just going to put that in brackets so that I know the 1/2 multiplies by everything. Okay. On this one, u is 2 over x. du is -2 over x squared dx. And then I get x squared over -2 du equals dx. So, kind of out of room here. So we get the integral of e to the u divided by 3x squared times x squared over -2 du. So our x squareds are going to cancel out, and I have a -1/6 times e to the u du. So when we do the integral of e to the u, it's the same as the derivative. So this equals -1/6 e to the u. Don't forget your plus c, it didn't have limits. And then our last thing would be to plug in our 2 over x. So we get that -1/6 times e to the 2 over x plus c. Okay. I notice on this one, this has a 4th power and this one doesn't. So this is probably my u. So du would be e to the x times e, or plus e to the -x times -1. So minus e to the -x, basically, right? And so when I divide that, I notice that the top's going to cancel out. So I get 1 over u cubed du. Okay, so this is u to the -3 du. That gives us, we're adding 1. Oops, I should have wrote 4, not 3, sorry. So 4, and then I add 1 to that. So I get -3, and then I divide by -3. So I get -1/3 u to the -3 plus c. -1/3, and then u was e to the x plus e to the -x to the -3 plus c. Okay, our last one. If u is e to the x and du is e to the x dx, so I get 1 over e to the x du. So e to the x times the cosine of u times 1 over e to the x du. E to the x cancels out, and then taking the integral of cosine, which is the sine of u plus c. So the sine of e to the x plus c. Okay, so we're doing the same rules that we did with all of our u substitutions before. We just have to follow the integral rule when we do it. We have to make sure that we know what the integral is of an exponent that's not an e base. Okay. All right, let me know if you have any questions. And I will talk to you tomorrow.